My name is Marc Deshusses, and I'm a professor in the Department of Civil and Environmental Engineering here at Duke University. My training is in chemical engineering. What fascinates me is to develop new solutions to important environmental issues, in particular air treatment, water treatment and sanitation. In the world, there's over 2 billion people that don't have access to a decent toilet. The implications are huge because there's a lot of fecal matter that ends up untreated in the environment, and it leads to diarrheal diseases, parasites, and other health impact on people, and it affects disproportionately poor people. One of the very exciting projects that we're working on is a neighborhood treatment system that can handle the fecal waste for 1,000 or 3,000 or maybe even 30,000 people. And it works with a novel process that is called supercritical water oxidation. Supercritical water oxidation is a high temperature, high pressure process, the pressure cooker on steroids. The temperature that is reached in the unit is in excess of 700 degrees Fahrenheit and the pressure 240 times the atmospheric pressure. At these conditions, the organic matter in the fecal waste burn extremely fast. So in something like 4 seconds, we go from fecal waste to carbon dioxide and water. We started to work on this project in early 2013 with funding from the Bill and Melinda Gates Foundation. It's a part of the Reinvent the Toilet challenge. The project went through different phases with a lot of design activities. Initially, our research was really towards demonstrating reactivity of the fecal waste and showing that supercritical water oxidation can convert fecal waste into clean water and energy. A day with a typical run would start fairly early, and it goes through a process of first preparing the feed, heating up the unit to the proper temperature and pressure, and then feeding the waste into the system. The unit is all computer controlled, so we have a little command center. We monitor temperature, pressures, flow. Typically, the engineers will change certain parameters depending on the objectives for the day. Lately, we've been putting a lot more focus into recovering this energy and being able to run the unit with just the energy that is embedded in the fecal waste and not depend on the electrical grid. The potential of supercritical water oxidation is enormous because you can build units that are very compact, can be embedded in communities, or you can build large units that can treat the waste of small cities and turn fecal waste into clean water. The challenge is really in engineering a system that can do it reliably and do it economically as well. The fact that the end goal is very noble motivates all of us. We know we can do it, and that's, I think, one of the motivations is keep pushing to achieve success.